Hello, good morning. So now let us see the constructional procedure and steps for the epicycloid with a simple example. Right. So now let us see the problem. Draw the locus of a point on a periphery of a circle which rolls on the curved path, that is rolling on the another surface of the circle. So next one. Take the diameter of the rolling circle is 50 mm and the radius of the directing circle or the curved path is 75 mm. So that already the definition of the epicycloid is nothing but the curve traced out by the point on the circumference of the circle which is rolling on another surface of the circle and outside it for one complete revolution without any slip is called epicycloid. So let us go for the constructional details and what are the different constructional steps for the construction of epicycloid. So now these are the solution steps, that is 1, 2, 3, 4, 5, 6, and these are the construction steps. So we will go one by one. So one smaller circle will roll on the larger circle for one complete revolution. It will cover a distance of pi d distance on arc and it will be decided by including an arc angle theta. So how you are going to find out the theta? Because in case of cycloids it is a straight line, so that you have calculated the length of that one as pi d, that is circumference of the circle pi d, but length and arc is not as the same length. So you have to find out the angle such that the pi d in the form of arc. Okay, so to calculate theta by a formula, that is nothing but theta is equal to, that is 2 pi r by 2 pi capital R. So 2 pi capital R means that is the circumference of the rolling circle divided by circumference of the directing circle. 2 pi gets cancelled, so that we get here small r by capital R into 360 degrees. So here it is mentioned as 0, but this is 360 degrees. Right. Construct an angle theta with the radius OC and draw the arcs by taking O as a center, OC, and the radius of the sector with an angle theta. So right. So in constructing procedure we will see what are the different steps that which will include. So now this is center point, take it as O, midpoint of the directing circle, midpoint of the directing circle with the radius of capital R. What is the capital R radius? That is directing circle radius is 75 mm. So take 75 mm as the radius and draw an arc. Okay, draw an arc. So now from this point as a P, just you extend it. Okay, this is nothing but the directing circle, and with the radius of 25 mm, this is diameter of the rolling circle. You see clearly this is the radius of the directing circle is 75 mm and the diameter of the rolling circle is 50 mm. Don't confuse in the dimensional units. So this is diameter, so you have to take 25 as a radius, and this is a radius. You can directly take 75 mm from O and you can draw an arc. So now take 25 mm as radius with the center C, you draw a circle. Okay, this is called the generating circle, or you can call it as a rolling circle. Right. So after that, locate the extend the line here. Okay, such that this circle is going to divide into 2 equal parts. Then next one, this is the center point C, where we can divide this circle into 8 equal number of parts. After making 8 equal number of parts, just give the numbering 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, and this point is P. So locate this point as P. Okay. Then now with the center as capital O, P as a radius, you are drawing an arc. Right. So to find out this P for one complete revolution, if it rolls on this generating line, so this P will contact as P dash at this particular place. So what is this length? This length of the arc should be equal to pi d. So the length of the distance that is covered by the arc is pi d. So you have to find out theta. What is the small r? Small r is nothing but 25. What is capital R? That is nothing but 75 into 360. That is nothing but 25 by 75 into 360 is that you can calculate the arc, that is 25 by 75 into 360 gives rise 1 by 3 into 360, that is 120 angle. So theta is equal to 120 angle. Just leave it, keep it aside. So from O as a center up to 4 as a radius, O4 as a radius, draw an arc. And next O5 as a radius, and 3 will be same, 3 and 5 will be on the same line. O5 as a radius, draw another arc. O2 as a radius, draw another arc. Okay. Next O1 as a radius, draw another arc. Right. Then next, by taking theta degrees as 120, let's simply draw a line. So this is small r by capital R into 360. Okay, so divide this 120 degrees into how many equal parts? 8 equal parts. So as we have made 8 equal number of parts in the circle, such that this theta degrees is going to divide this into 120, that is 120 divided by 8. So whatever the value that is going to get, to divide this circle by the line bisecting method, angle bisecting method. So divide by this and draw the different locating points, and also give the naming for the different lines. So from C1 as mark it. So when the center C is here, the P lies on this particular rolling circle. So the first center, so when this circle is going to move in clockwise direction, this is going to be moved here. This center once come as C1, and this is C2, this is C3, C4, C5, C6, C7, and this is C8. So you can mark individually the centers of the circle. So after locating the centers of the circle, just mark it as C1, C2, C3, C4, C5, C6, C7 and C8. With these respective centers of this rolling circle or generating circle, with C1 as a center, with radius as CP, this R is equal to CP here. CP as radius, C1 as a center, make an arc on the 1, 7 line. So this is the one. C1 as a center, this one blue line indicates the radius, that is CP. You can make an arc. And C2 as a center, you make another arc on 2nd, 6th line. This one, this arc. Next, C3 as a radius, make an arc. C4 as a radius, another arc. C5 as a radius, another arc. C6, C7 and C8. So these are the points, intersecting points P2, P3, P4, P5, P6, P7 and P8. So now all these point of intersections, just please give the naming of that one. Naming, that is P1, P2, okay, wait. So after indicating all these lines P1, P2, P3, P4, P5, P6, P7, so simply draw the freehand curve from all the point of intersections such that you will get the epicycloid. So this is the normal epicycloid construction method, and for the tangent and normal you can go for the another video such that you will get a clarification on the tangent and normal. Thank you very much.